I don't like this picture. Okay, so we have two Ethernet adapters here, right? So one is Ethernet 0 and Ethernet 1, but in this case, what we're going to do is we're going to use two Ethernet adapters. So what will happen here is actually, I'll leave this on switch 1, switch 0, okay? So we have this server here. So the server we have here is host name, right? So we have this is the server we are working with. Okay, so this is the server we're going to work, and this is the adapter attached to the computer here. So let's see, the adapter we're going to use is ENP03 and 08. Okay, so we have ENP03 and ENP08. Okay, so what will happen is we're going to bind this together, and then we're going to make it a bond 0. So what will happen is bond 0 will be active, and ENP0S3 and S8 will be controlled by bond 0. Okay, if ENP0S8 goes down, ENP0S3 will pick up. If ENP0S3 goes down, ENP08 S08 will be on, and the bond is the one that the system will be getting connection through. So the system will never know what happened. Okay, they will never know what happened, but it might have the negative effect. It may not have a negative effect if the system went down, the link went down. Okay, so what I'm going to do is, so we have ENP0S3 and ENP0S8, right? So what I'm going to do is, give me 1 second here. Mara, where is the iPad switch? Okay, so to reiterate, we have two adapters here. We have two adapters. What is happening here? Give me just a minute here. Okay, so we have adapter 1 and we have adapter 2. One is active, other one is passive. Okay, so active and passive means this is standby, and this is working right now. And this is the one bound 0 will control it. So now the reason we have this is in the event, and this is going to the two different networks, network 1 and network this is network 1, and this is network 2. Okay, so what happens is if the network goes down, for example, if this goes down, then automatically this will become active. Okay, and if that goes down, then it already the other one is active already. So all this happens in a fraction of a second. Why do we need this? Because we don't want any server going down anytime. Server should never go down. That's the ideal situation here. The reason being is a lot of servers they're running the business activity, so they are making money for the company. Okay, so the moment it goes down, it will the company start losing money. So the technology has advanced so much that you are able to do all these kind of things here. Okay, any questions so far? What we're gonna do is we're gonna go ahead and configure it, and then I'll demonstrate you. If we bring one down, the other one will be up and running just fine.
Here, two switch means two network.
Yeah, I mean At work, they set it up as such, I mean, the networking part, we're not worried about it. It's a totally different team who take care of that part. And when it comes in here, so switch 1 is totally different network and switch 2 is totally different network. And then it's coming in here, and you could imagine 1 is active here. So the moment the active one goes down, the passive one takes over. And the business people wouldn't even know what happened, but there is a monitoring setup on the system that will trigger a alert. And there is another team, most of the time the team is sitting in India, what they're doing is just monitoring the system. And if they think the system is not back up, then you will get a ticket and you will work on it. Okay? All right, very good. So let's move ahead here. So what we're going to do is we're going to first identify the server we're going to work with. I think I just identified it here. We're going to work with ENP0S3 and ENP0S8. We're going to bundle this together and create bond 0. And bond 0 will be master. ENP03 and ENP08, they will be slaves. So what will happen is if one slave goes away, other one will pick up. So how are we going to do that? Okay, so let's see here. What we have to do is we have to go into the configuration file and configure it. So let's go ahead and so we will use configure prepare for NIC bonding. Configure adapter ENP0S3. All right, so let's go in there and then we'll configure it. VI
what is the command for network scripts?
Yeah, I'm going to do PWD. Yeah, get in this folder here first. Are you in there in that folder, right?
Yeah, I'm the root.
No, yeah, you should be root and then go into that folder. CD etc sysconfig network scripts.
Okay.
Okay, now do ls there. You should have ENP 0S3, 8, 9, and 10 is missing actually. So I'm not worried about it. I'm worried about ENP0S3 and S8. Okay, so let me go ahead and go in there. VI IFCFG ENP0S3. This is a configuration file related to the ENP0S3 network adapter. Okay, so what are the entries you would need for this to be successful? These are the entries you need. You need the type Ethernet. I think we don't need that. Give me 1 second here. So what do you really need is, do you need type? Let me see here. You don't need type. Boot protocol. Yeah, you need it, but you should set this up to none. NONE. Okay, and then on boot is yes. And device, you need it, and the name, you don't need it. Okay, and then the hardware information, all this, you don't need this. Okay, and now what we're gonna do is we said slave equal yes. This is a new entry we're learning today. SLAVE. Make sure it's spelled correctly. Okay, and master equals bound 0. Okay, you should decide what is the name you're going to use, bound 0, bound 1, whatever. If you want to refer to as bound 0, then this is just say bound 0. Okay? Good. Now configure adapter ENPS ENP0S3. I keep forgetting 0S8, and this is ENP0S3. And if you visually look, it's going to be the same exact thing in here. The only thing is going to be different is ENP0S8. Okay, so I'm going to save and exit here. I'm going to bring up ENP0S8, delete everything in here. Just hold on letter D and it will delete everything for you.
Can I see that ENPOS03, like what changes here? Give me 1 second, baby.
Yeah. 8.
Okay, I'm done. Thanks.
Okay. All right, let me get out of this. And this is
And we did the same thing on 08.
Yeah, 03 and 08. Almost everything is the same exact except the device name. Device name is just make it 0. Okay, now what we need next is, looking at the diagram, we need bound 0. Okay, let's go check in the system if the bound 0 is already there. So I'm in my system here. I'm going to do ls, and it's going to be have to be in the same directory, because this directory holds up all the information here. So I am looking all this here. I don't see a bound 0 in here, right? So what I'm going to do is I'm going to create one. Okay, the name is going to be same exact name, vi ifcfg hyphen bound 0. Okay, we are doing vi. Remember that this file doesn't exist, but we're still using the vi command to do it. Create a file ifcfg hyphen bound 0. Okay, so I'm just keeping this as a copy here, but we're gonna edit this here because this one needs a little different input. So I go in here and I go into edit mode, and the device is going to be bound 0. Okay, and over here on boot is yes, and there is one more entry here, type equals bond. Notice you have to type bond in B capital letter, BOND. Okay, I don't know why it's so inconsistent. And here you say on boot yes. Boot proto, what you're going to do is static. We are physically assigning the IP address to it. Okay, and here you don't need this 2 lines. So what you're going to do is you're going to add IP address IPADDR equals. So what I'm going to do is I'm going to take the IP address which is not even being used at all. So I'm going to say 192.168.56. I think we use 120, right? So let's put down 250. Okay, and net mask, I think I told you yesterday, net mask will never change. So it will stay 255.255.255.0. Okay, that's all you need. Let me know you're ready.
Actually, I'm still a step behind. I was still doing the 08. So what are the steps after that?
Um,
We went into
so all you have to do is bond 0 doesn't exist, so create one in that folder. You should be in, if you do pwd, you should be in etc sysconfig network script.
yeah, that's where I am.
Okay, so go ahead and type vi ifcfg hyphen 0 bound 0.
And then ENP, oh, and then bond 0.
Yeah. And then put in this input in there. Delete everything and put in there. I mean, there shouldn't be anything in there to begin with.
Right.
So VIIFCFG bond 0 means we have to create another folder, right?
No, it's not a folder, it's a file.
File, yeah.
And make sure you are in a correct place. When you type pwd, it should reflect what you see here.
Yeah, so the bond 0 is not existed, so we created.
Yeah, you're creating it now. Exactly.
Okay.
For the type, it has to be capital B. Bond
Yeah.
capital B. Yeah.
For some reason, that needs to be in uppercase.
Master.
Okay.
Okay.
So the next step is going to be, then what we're going to do is we're going to create a configuration file which will enable the system to recognize this. So create a bond configuration file. Create bond create bonding configuration file. So what is going to happen here is, so the location of that file is, let me save and exit, clear this. So the folder you're going to go to is cd slash etc. Remember, etc is a configuration folder. Mod pro .d. It's a folder. Remember, the folder name is mod probe.d, and hit enter. And if you do pwd there, you should see etc/mod probe.d. In here, we're going to create a new file which doesn't exist. vi bonding.conf, bonding.conf. I'm going to stop here so that you catch up. Okay, so if you confirm you're there, then I'm going to go in there. Bonding, vi bonding.conf, conf.
You're there.
Okay, so I'm going to hit enter, and what all we're going to do here is we're going to just put one line in here. Okay, I'm going to say alias bond 0 bonding. Okay, that's all you need to put in there. What it tells the operating system that go check for this bonding for bond 0. Okay, so I'm going to save and exit. Now the last thing is activate bonding. Okay, how are you going to activate it? It's pretty simple. The command to activate bonding is mod probe, modprobe. Remember, we did part probe, right? Earlier when we were we did part probe one time. You should have remembered. What it does is it will search up the partition. When we did mod probe, this is gonna search up anything which has been changed. And hit enter. If you don't get any error message, that means it has worked. So the bonding is active now. Okay, so let's see if it's really active or not. So the command is lsmod space pipe grep bonding. Okay, so this is the proof that it is working. It is active right now. Verify if the bonding is active. And this is the proof that it is active. Okay, now what I'm going to do is I'm going to restart the network. Restart the network to actually restart the network to make adapter work. Bonding works. Okay, so now what I'm going to do is, how are we going to restart the network? Simple. Systemctl. Okay, before that, I'm going to type if config and hit enter here. So what will happen here is we have ENP0 S3, S8, okay, and ENP0 S9, S10. So there will be another entry in here. It will say bound 0, and the IP and this information will be S3 will look like this here. It doesn't have any IP in here, okay, but I'll show you which one is being used. So let me go ahead and clear the screen. I'm going to say systemctl restart network and hit enter. Okay, so I didn't get any error message. That means it restarted successfully. All right, now let's go ahead and take a look at CFG ifconfig ifconfig and hit enter. So let me expand the screen, or maybe not too much. So you see here automatically bound 0 is active here, and look at the IP address. This is the exact IP address we set up. Okay, we want it to be 250, and if it's 250 is not being used, then this is the exact IP address bonding has given us is 250. Okay, but how do you know which one of this is using? Which one of from the diagram is it using ENP0 S3 or 0 S8? How do we know that? So the easiest way to look at it here is look at the hardware address here. Hardware address right now it's using is this here 08. This is the hardware address. Now compare the hardware address between ENP0 S8 and ENP0 S9. So look at it here, 0080027 5D 8F A5. Okay, and then you look at this here, hardware address also is 00275 5D F8A5. Okay, so both of the hardware address is same, huh? Let's look same, yeah. So now you see the hardware address is being same here. Normally they should be different. Why is it same? AF Give me 1 second here.
I think mine are not the same.
Yours is not the same, right?
Right.
That is bizarre. It should never be the same.
Oh no, actually they are the same.
Is it the same for you too?
Yeah. You're talking about ENP0S3 and ENP0S8 or ENP03 and bond 0?
Okay, so whichever one is active, so S8 and S3 should be different.
Yeah,
That
they're
is
different.
for you.
They're different. Yeah.
The ether, when you say ether,
But bond 0 and ENPS3 are the same.
yeah, because it is using ENP03 as a primary. Then if something happened, then it will use 8 as secondary. So why is mine like that here? That is bizarre. Let me go in here and take a look. Okay, the MAC address here is 042EA. So the MAC address over here is showing different. Why is it? See, if you see here, the MAC address is different here when you actually look on the network card. Maybe I need to restart this sucker here. So it's just for me here. Let me just restart the system. Or let me restart the network one more time.
My address is both are also same.
Yours is same too?
Yes, sir.
You're looking at the ether, right?
Yes, sir.
ENP0S8 and S3 should be different.
No, my is same.
3 and 8 are same.
3 and 8, yes, sir, both are same.
Okay, let me restart the network one more time.
And bond 0 is also same.
No, the bond 0 will match either ENP0S3 or S8 because it's just mimicking what it's showing there.
I have to check the VI file for both.
Yeah, we could check it. That's a good start to troubleshoot. Who's that?
That's Arun.
Harun, very good.
That command is not working, it shows error.
What command is not working?
System CTL restart network.
Yeah, system SYSTEMCTL space restart space network.
Yeah, it shows error.
So let me go ahead and restart the system. See, remember we deleted from FS tab, now it's causing problem here. So that's why the system reboots. Okay. Okay, 002. Again, it's this is so mysterious for me. The Ethernet card should never change. You know what? Let me run the different command here. IPA. IPA gives much more detailed information here, and I'm sorry, the So what is it using? Bond 0 here it's using 00276A8. All right, let's try what Harun said. Maybe so I went into VI. Let's go into cd etc sysconfig network script. Okay, so let's go into ENP0S8 first, or S3 first. And we have device ENP0S3 on boot yes, boot proto, none, slave yes, and bound is, master is bound 0. Okay, this looks good. S8 device on boot yes, boot proto, none, master bound 0. This looks good to me. Type bond 0, and so let me bring the link down. IP down. IP link. I think I have. Let me try IP link set ENP0S3 down. Oh, okay. You see here, I brought down what I did was here I brought down S3. S3 is not listed in here anymore. I brought it down, but this is still working here. But I still didn't get it. The MAC address is, you know what? Actually, the MAC address is creating is random anyway. It's not the MAC address of either of the network interface card here, right? So let me see. 80042EA, and it's supposed to be FA. It is using MAC address for one of the other. Let me restart system CTL, restart network. Three is back, and it's stuck using the MAC address for 3. IP-S link.
Can I ask you a question?
Yeah.
So in my VI file for ENP8, I did not put the master as a bond 0. That's why it was working. When I changed it, now I have the same issue. It's showing the same MAC address
Yeah.
for P0 ENP8.
Okay. All right. So let's see here. Let me put in. Okay, boot proton none, on boot yes, master bound 0, slave yes. On boot yes. All right, let's go back in here and let's go ahead and put in here name equals enp0s8 and let's go ahead and put a type back also, type equal Ethernet, right? So I'm going to go back into cd/etc sysconfig network scripts. So I'm going to go into vi ifcfg enp0s3. In here, what I'm going to do is I'm going to put the name back in there, type, and this here. So okay. Uh-oh. This is S3. 3. Name, device, type Ethernet, boot yes, boot proton none, slave yes, bound 0. Okay.
Is the boot proto should be static or none?
It should be none. It's not like here, over here he's using none also. Because bond 0 is, when we go inside bond 0, he's using as static. Here he's using static. Let me go ahead and restart it. Yeah, it's not changing. I don't know why. So if we look at our original, the one we worked yesterday, right? For ENP0S3, this is it's for some reason it's kind of stuck with this information here. But anyway, the bounding part is working. If I bring ENP0S3 down, right? IP link down, IP link set down. Okay, and if you do if config, the link is not there. ENP0S3 is not there. But you still have the IP address available for it. This is working. Okay, so what I'll do is, let me shut it down, and what I'll do is okay, it's down. And I'm gonna tell him use the totally different MAC address for both of them. They all should be different here. I mean, I don't know why they're not different. Okay, all right, let's bring it back up. Woohoo! It's still using the same one. I bet what Bond is doing is, since this is in the order here, it's automatically picking up for it's automatically picking this up and assigning it all across the bonding. Because if you look at here, 1C84, right? So if you look, see 1C84 and network card is, the other one is different.
Matt.
Yeah.
Oh, I was just thinking if we should do an experiment, like I said, if we take the master line out from one of them, and then shut down the one that does have master line, and see if it picks up the
Yeah.
other network card. Because by taking the master line out, it is showing two different MAC addresses for both of them.
Yeah, but what we could do is, yeah, why not? Let's go ahead and do that. If you take the master out, then Bond wouldn't
Right.
know which to use, right? If so, I take Bond 0 out.
And if you restart restart the network.
If you put a comment out, it's gone. Yeah, it's taking 49 now. And this is 84. And see, it's using 49 right now. It's not even recognizing this here. Okay. So you see the difference here? That's a good thinking, Adil. So right now it is using, it's not even recognizing ENP0S3, right? And it's using, Bond 1 is using this here. So if we shut down 8, ENP0S8 down, and Bond 0, is it working? Eight is not in the picture anymore, and it's still using 49. So let me restart the system.
It doesn't work.
You restarted it? Oh, 8 is back. So it is using 49. Let me see, it's working. In my previous classes, I didn't run into any of this problem. But anyway, realistically speaking, this is how it works normally. I mean, you don't have to worry about it too much because maybe when we're gonna do the update, system updates, there are some things which are we need to be update here. So when we run system update, maybe it will come back up or fixes some problem. Okay.
I have a problem with restart the network.
It won't restart, right? So you did system CTL restart?
Yeah, system CTL restart network. It shows error.
You're typing it correctly, right? System CTL restart network.
Yes.
Okay, give me your team viewer.
Nine 3199963.
And the password?
QDTS 4 ACS.
QD
TS
3S.
TS T as in Tom.
Okay, hold on. QD TS
4
O
no number 4
4
ACS.
Sam Edward Sam.
A as in apple, C as in cat.
AC.
No, okay, I'm telling again. QD
Mm-hmm.
T is in Tom, S is in Sam.
Okay, hold on, buddy. It says license maximum duration partner. Shoot. The connection timeout. Do you have okay, go into Google. Go to this link here. Google, let's try Google. I'm putting this in the group chat. Click on there and go there. Because TeamViewer, I think it's erroring out now. It's not working as good. Did you get there?
Yeah.
Well, okay, go ahead and download and give me the access code.
Can we take a 5 minutes break after this?
Let's go ahead and do it now. Everybody come back at 12:15. 15-minute break. Okay. All right. Bye.
Thank you.
Number is 2982
Yeah.
3811
3811.
9946.
I think you have to allow on your end. Okay. Okay. Network services failed. Oh, can you put your password in? Put your password in.
Yeah.
Okay, your network is working, but there's error messages coming up here, so it could be any reason. What we'll do is we'll just leave it off here, and I'll check your system later on. Okay?
Okay.
Yeah. Okay, let's move on. Here's the thing here. So far, it did work. Whatever we did in the configuration, it did work here. The only thing that was there was the IP, the MAC address. I don't know why it's not using the correct MAC address. I'll find out more, and I'll let you know if it's important or not for this class here. But as far as the NIC configuration goes, when you look at the NIC bonding, the bonding part is working just fine. How do you know that? If you do ifconfig bond 0, it is giving you the IP address that you assigned, and it is working.
Or maybe it's possible that it just bonds it into one MAC address for both NICs.
That's what it sounds like here. I mean, it's picking up the primary as a MAC address, and it's just sticking up with it.
Yeah.
So what is happening here, I'm thinking, is since both are slaves, S3 and S8 are slave, so it will just grab whichever MAC address and uses itself, and it just doesn't care. But in principle, I thought it will reflect what MAC address it's using, because S3 goes down, it will give you a confusing result, because you say S3 is down, but it's still using the MAC address for S3. So let me search up on that. If it's necessary, I'll come back and give you more information. If not, then we know it worked. Okay, so first thing first, yesterday I told you everybody to download that pre-configured operating system here. Please go ahead and download, and then towards the end of the class it will look like this. Okay, it will look like this, and you should go ahead and download that, and then we'll configure that before the class is over, so that once the access for my online thing is gone, you could download it locally and then continue working on it. And last day we will work on the resumes and everything, and then we'll prepare it. And after that, I will schedule. So now I still do have some topics I need to cover. So let me see which one I need to cover here. So let's cover the system boot process here, okay? I'm in October already. So I'm gonna cover a system boot process. So this is only informational. You don't need to worry about all this here. So what happens here is when the system starts, is going through all this, there's a lot of activity it goes through here. For example, I'm going to show here, I have a local system here. So you have this system here, right? So what is happening here is, if I may put it to the side, I'm going to restart the system. So when the system is restarting, it goes through all these things here. And it happens like so fast. It happens within few minutes. So first of all, what right now where the system is sitting is, let me reset it here. So by the time the system comes up to this screen here, it has already ran through the BIOS part and the MBR part. Right now it's sitting at grub 2. It says Linux kernel image. So here we have a Linux kernel image in here, which is it's sitting at. Okay, I interrupted it would have continued on. So what happens here is, if I continue on, then it's going to do all the necessary driver modules, and init RD image is going to check into that. And you see all these files are flying by because it's the boot process. It's going to check into all those things and all. And it's up now. So from the time it's restart and from the time it comes back to this screen here, let's see how many seconds is that. Started at 12. Okay, so it's up in about 30 seconds here, but it's going through all this, it's going through all these processes here, and these processes, from the time it started from BIOS, from the time it started, ended up at systemd, the process is very complex. It did a lot of things in the background, and all these things didn't develop over the years, overnight. It developed many years. All this thing happened many years in the making. Some company came up with BIOS, some individual came up with grub, then grub 2. All these things took years for it to become a part of an operating system. So what I'm going to do is I'm going to break this down so that you have a little better understanding here, but this is only informational, okay? So what happens is, very first thing is the computer is powered on, right? When you push the turn power on button on the computer, it's powered on. And then what happens is it reads the BIOS. It's called BIOS, the very first one. It is a basic input output system. BIOS is basic input / output okay, and it is a physical It is sitting on the motherboard. It is a physical chip sitting on a system board. If I could look at the picture here. If you open up a system, you see a physical chip outside of the operating system. It's sitting in there and it controls the basic input output system here because it checks the operating system and all those things. So BIOS performs post. It performs post. What is post? Power on self-test. When you turn on the system, it makes like beep noise and all that, right? That's what it is doing. So it's basically a health check. Okay, and number 5 is where if all that is good, then what happened? It loads the MBR. So what it does is it passes control to master boot record. Control to MBR, which is master boot record. Okay. In general, it's called bootloader. And it sits inside MBR on hard drive. A little fraction part of the hard drive has something called MBR, master boot record. If you look at here, you have the hard drive here, right? A tiny portion has a master boot record. It's like it's a very small sets of instruction code that does a very important thing here. So it goes through it's like 440 bytes, 4 bytes, 2 bytes. It's not much, very small information here. It's under 512 bytes. Way small. It's not even 1 megabyte. Okay, so what it does is it has a very important instructions, code of instructions. It helps in the boot process. And the bootloader has 2 stages. Okay, so this is a continuation of the boot process, right? So it will be number 6. So what will happen is first stage of bootloader passes control to second stage. Okay. So if you look at the picture here, partition table, master boot record. So here you have like a bootloader stage 1 MBR, bootloader stage 2 grub bootloader. So it is stage 1 and stage 2 is actually inside MBR, but it's doing a lot of other complex stuff here. Okay, so once it does that, now we are into second stage, right? Second stage of bootloader, it resides in /boot partition. Okay, so let me go inside cd grub. Let me see if it's hidden. Okay, it's not showing up here, but believe me, it sits into the /bootloader. Okay. So what happens is second stage of bootloader loads. It loads this file here. It loads the file which is named this file name. It's a kernel. It's a kernel file. VM Linux. In this case, it loads this file here, VM Linux. This is a backup. This is a backup of this file here, and okay, if you look at the kernel version of the operating system here, you see this is the same version as this here. So what it's doing is it's triggering the kernel to load. Loads the VM Linux. This is an example here. If it's a different kernel, it starts with VM Linux, but this part will change. The version will change. It will load this kernel file. Okay, and when it loads it, it extracts it. Also extracts the content of the file. Is going to extract this file here. If you look at this file here, this file is like an image file. where does it extracts? It extracts it into the memory. Okay, and this file also loads the drivers. Okay, so what are the drivers? If you have like a USB plugged into the operating system or into the into the computer, it will load the drivers for the USB to work. Okay, if you bring a hardware and just plug it in, it's not going to work here because it has to establish a communication. It's called drivers. And it loads the drivers. All those things are sitting inside this image. Okay, and then the 10th point is the kernel file starts the first process of the systemd. Systemd means system daemon. Okay, so where are we at? So we did the power on happened, MBR happened here. So the MBR happened from number 5 and number 6. Okay, and from number 7 to number 10, what happened is the kernel part happened so far. And then the systemd process is starting now. Okay, so the kernel starts the first process of systemd. Okay, now the systemd is in control. Systemd is in control. So what happens in the systemd? So systemd is the 11th in the process. And within systemd there are smaller things happening. Okay, there are other smaller things happening in systemd. Oh God. Okay, so what is the very first one? It reads the configuration file etc systemd. It reads the configuration files, I should say, inside etc systemd directory. Let me go in there. What does the etc folder stands for? See, it has all this configuration file, right? .conf and all that. It will read those files. All these things is happening, within seconds. While here, while there, it also reads run level file, which is etc systemd system/default target. cd system, no. And if you do ls here, we have our default file name. if we cat the file, if we go inside the file here, there are some configuration here how this is being set here. Right now the system is set to multi-user system so that many people could connect to it, and it requires the basic target, and it has some information here. I would say don't worry about that, but just so you know, it reads this file. Okay, so whatever etc, so whatever target is set inside this file, system will be in that mode. Most of the time either it's a graphical mode or multi-user mode. Or graphical. I mean, in Linux there is some GUI available, but you will never use it. Never. I've been in Linux for so long, I never use it. Okay, and what happens after that? Here it reads the configuration file and reads the file linked to the etc default and brings the system to the state defined by system target. So the system target is called run level is loaded based on this file. So this file, the system reads that file, and whatever run level is in that file defined, the system will come up in that configuration. And finally it executes etc rc.local. Let's see if we could take a look at this file. Vi etc rc.local. Okay, so it's not doing anything in here. Why is it not doing anything? Okay, so this is not necessary. I don't know where I got it from. Okay, so one more time. All this is happening in about 30 seconds. You see, you have a run level and all that, and all this is happening within 30 seconds. It has so many files that I cannot really stop this, but it's going through all this process here. One file leads to another file, and etcfs tab is one of the file that is read during this process. Okay, that's about it in here. This is purely informational. I would say don't worry about this, and you probably won't be quizzed what is actually happening here. Okay. All right, so I'm going to stop here, and we still have a few more topics to cover, and next week we still have so I would say we still have 2 more weeks, about 4 more days, so we'll work on that, and then after the class is over. Okay, now what I'm gonna do is for this week we probably didn't do much. Go ahead and set this up, network bounding and all that, configure the networking, and whenever you're setting up like a static, go ahead and have some fun. Change this last number around, set it to 150, 147, keep changing it like 10-15 times, and pick the number whatever you want and restart the system. Don't use the one which has already been used. So if you do if config, don't use the one which is already being used, like 10. Don't worry about the 10 network. Just stay with 192 network. 192.168.56 dot, and then change around the last one and have some fun when you are setting up a static IP. And what else we have? In fact, let me go through this, and then I'll set up, I'll give you the assignment. Here, these things you don't worry, don't do it every day, but it's only one time setup though, configuration, network card and all that. And then next week, we're gonna go over a little bit about scripting, how you properly script. The way I showed you is like basic, simple, but I'm gonna show you a little bit more than what you need to know. And after that, after that, that's about it. But before next class, make sure you have downloaded that file I put in the chat. Download and keep it ready. It's about 700 megabytes. And then I will set up your local machines so that you have access to the system on your own. Okay, anybody have any questions? Put that into the group chat. And if there are no questions, then I will end here today, and we'll catch up next week.